All right, it's College Algebra Final Exam Review for UALR number 22. We have a problem that says the manufacturer of lighting fixtures has daily production cost of C equals 800 minus 40x plus 0.25x squared, where C is the total cost in dollars and x is the number of units produced. What daily production number yields a minimum cost? This is a quadratic function, and so if this is the cost for those fixtures, what we're going to do, we're going to use the calculator to find the minimum. So I'm going to go to the y equals and I'm going to type in that function. We'll clear this and do 800 minus 40x plus 0.25 x squared. That's the function. Now I'm going to graph that, and I'm going to be looking for the bottom, the vertex of the parabola. And this is going to be opening up because my leading coefficient, the 0.25, the coefficient of x squared is positive. So I know this is going to be a parabola opening up. I'm going to graph this. My window may not be set very well. All right. One thing I need to know when I'm looking at this, and I don't see anything, I'm going to hit zoom 6 and see what we can see when we go back to a standard window. See if we see anything there. And if we don't, now we need to notice that first off, the y-intercept, the constant term, is 800. So I know I'm going to have to change my window here. I'm also dealing with numbers of fixtures. And so this is probably going to be a pretty good sized number. We're not going to care about negative numbers for x because we're not going to produce a negative number of fixtures. But I am going to change my x max. And I'm going to go ahead and change that to 100 and see what happens. We may need to make it bigger than that. We'll look at the graph. My y min, let's leave that at negative 10. Let's make our y max 1,000. Since our y-intercept is at 800, we need to go bigger than that. And let's graph this again and see what happens with that window. Now, this is kind of interesting. Let's double check our y equals 800 minus 40x plus 0.25x squared. That is the function. If we look again at the graph, we can only see one side of that. The minimum cost is going to be at the vertex. The vertex appears to be below the x-axis. This is going to be odd. It's an odd problem. Let's change the window. Let's make the x max, let's make that 1,000 as well. We're going to make it bigger because we need to see farther. Let's go ahead and change the y minimum to negative 500. And let's graph this again. Let's see what happens. All right, we don't need near that much x's. You can see it comes down and goes that way. So we're going to reduce the x max and we're going to lower the y min. So I'm going to hit the window again. I'm going to make my x max, let's go 200 this time instead. And let's go to our y min, let's go negative 1,000 and see if that does us any good. Now we'll hit graph. Now my problem here is that this suggests that we have a negative cost. That doesn't really make any sense. Production cost. But we're going to go ahead and find a minimum just in case we just say, I don't really like this problem. But we were asked to find a minimum, so the minimum on the quadratic function is going to occur at the lowest point at the vertex. I'm going to teach you how to find it on a calculator, even though it makes absolutely no sense in the context of this problem to be negative. So the minimum value being negative, we can find the minimum, the number of fixtures is what we're asked to find that produces that minimum value. So we'll be looking for the x value of the vertex, but still this problem makes no sense. We're going to do second trace. If we're looking for that minimum, we're going to look for a minimum. So we're going to highlight number 3 and hit enter. Then it says left bound. What we're going to do is tell the calculator where we want to look for this lowest value on the graph. We want to be on the left side of the point we're looking for. We're looking for the point at the vertex. So we're going to set our left bound to the left of that. Use your left arrow key to move over there somewhere to the left, hit enter. Be sure you're on the left side when you do this. Now it says right bound. So we're going to move our cursor to the right side of the point we're looking for. Make sure you're on the right side. We're looking for that point at the minimum. So we're going to move that to the right side. Set the right bound. Then it tells us to guess. Now when we hit enter, it's going to go find that minimum. There it is. And this is when X is 79.999986. That means 80 in the calculator language. It tells us the minimum cost is negative 800. That's what doesn't make any sense. But we're asked to find the X value here. So we're going to put 80 for our X value. And that's going to be the answer in problem number 22. And that's how you find a minimum.